Welcome grade 9 students to our lesson mathematics, all about quadratic equations. Our lesson in this video is illustrations of quadratic equations in one variable. Let's begin our lesson with this question. What is quadratic equation? Quadratic equation is defined as a polynomial equation of degree 2 that can be written in the following forms: ax squared plus bx plus c 0, ax squared plus bx equals 0, ax squared plus c equals 0, ax squared equals 0, where a, b, and c are real numbers and a is not equal to 0. The encircled terms determine that the equation is quadratic. Quadratic equation is composed of three terms. First, ax squared, which is the quadratic term. Second, bx, which is the linear term. Lastly, c, which is the constant term. Remember the pattern? Quadratic term plus linear term plus constant term equals 0. Now, examine closely the examples of quadratic equation. Still have questions? Let's move on to the next. Standard form of quadratic equation is the most important thing you must understand in this lesson. Ax squared plus bx plus c equals 0 is the standard form of quadratic equation. Remember, a, b, and c represent numbers. Let's find out how to determine the values of a, b, and c using examples. 1. 2x squared plus 5x minus 3 equals 0. The values of a, b, and c are: a is equal to 2, b is equal to 5, c is equal to negative 3. Clear colors indicate their respective values. 2. X squared minus 4 equals 0. The values of a, b, and c are: a is equal to 1, b is equal to 0, and c is equal to negative 4. As you notice, we have only two terms in this equation. The missing term is the linear term, so that's why b is equal to 0. In the case of quadratic term, x squared has invisible coefficient which is 1. That's why a is equal to 1. 3. 10x squared plus 5x is equal to 0. The values of a, b, and c are: a is equal to 10, b is equal to 5, and c is equal to 0. In this example, we have only two terms. The missing term is the constant term, so that's why c is equal to 0. Let's see more examples of quadratic equation. Write the quadratic equation in the standard form and identify the values of a, b, and c in the following quadratic equations. Let's have 10m plus m squared is equal to negative 25. If you notice, this equation is not yet written in its standard form, because sometimes the equations are not written in its standard form, so that's why it must be written in correct positions first and make the one side of the equation 0. And then, you can identify the values of a, b, and c. Let's process the equation. In this equation, we have applied the addition property of equality to make the other side of the equation 0. So, we have come up with an answer which is 10m plus m squared plus 25 equals 0. But we're not yet done. We have to arrange first the terms in its correct position. We have to follow first the pattern, which is quadratic term plus linear term and followed by the constant term. By arranging, we're going to have m squared plus 10m plus 25 equals 0. So now, we're ready to identify the values of a, b, and c, which are a is equal to 1, b is equal to 10, c is equal to 25. Remember the pattern: quadratic term plus linear term plus constant term is equal to 0. Let's see another example. 3x times x minus 2 equals 10 is another form of quadratic equation that is not written in standard form. In this case, follow this reminder. To write the equation in standard form, expand the product and make one side of the equation 0. So to expand this product, we're going to apply the distributive property of multiplication. We're going to multiply 3x times x and 3x times negative 2. Then we're going to come up with the answer: 3x squared minus 6x is equal to 10. So to make the other side of the equation 0, we're going to apply the subtraction property of equality. So we subtracted 10 on both sides of the equation. The equation becomes 3x squared minus 6x minus 10 equals 0, which is already written in standard form. So in this equation, the value of a is equal to 3, b is equal to negative 6, and c is equal to negative 10. So for our last example, we have 2x plus 5 times x minus 1 is equal to negative 6. And this equation is also a quadratic equation but not written in standard form. So just like in example B, equation 2x plus 5 times x minus 1 equals negative 6 can be written in standard form by expanding the product and making one side of the equation 0. And to expand this product, we're going to apply the FOIL method. We're going to multiply the first term to first term, outer to outer term, inner to inner term, and last to last term. So the answer is 2x squared for first to first term, negative 2x in outer to outer term, and positive 5x in inner to inner term, and negative 5 for last to last term. So we have 2x squared minus 2x plus 5x minus 5 equals negative 6. I hope you got it right using the colors. And then, to make the other side of the equation 0, we applied addition property of equality. So we added 6 on both sides of the equation. We got 2x squared plus 3x plus 1 equals 0. We combine the similar terms, which are negative 2x plus 5x, so we got positive 3x. The equation is 2x squared plus 3x plus 1 equals 0, which is in standard form. The values of a, b, and c are a is equal to 2, b is equal to 3, and c is equal to 1. To sum up our lesson, remember that the standard form of quadratic equation is ax squared plus bx plus c equals 0. To write quadratic equation not written in standard form, make one side of the equation 0 and arrange the terms. For quadratic equations written in the product of a monomial to binomial, apply the distributive property of multiplication in expanding. And for quadratic equations written in the product of two binomials, expand the product by applying the FOIL method. Thanks for watching. I hope you had fun and have learned in this lesson.